In this example, what we're going to be looking at is Rutherford's experiment. And what Rutherford's experiment was, is it had a thin foil of gold, and what they did is they bombarded that thin foil of gold with some alpha particles, Now, alpha particles are the nucleus of helium atoms. And the result of this experiment was that when they sent in the alpha particles into the gold foil, some of the alpha particles recoiled off or were deflected. And what that showed is that there was a nucleus, that there was something there that they had not realized. So prior to this, they thought Lord Kelvin had come up with the idea of the structure of an atom as being similar to a blueberry muffin, where the bread represents this positive ether stuff, whatever's positive, and the blueberries would represent the electrons. Now, they had discovered the electrons, Millikan's experiment, or I shouldn't say, but they had discovered the electron. They knew that it was something negative, but they knew that there had to be something positive, but they did not know the structure of the atom. And so along came Rutherford's experiment by sending in alpha particles into gold foil, and then the alpha particles getting deflected off of that. And so what we're going to look at in this problem is we're going to try to determine the radius of the of the gold nucleus, And the equation we're going to be using is going to be the kinetic max is equal to a proportionality constant times the charge of the alpha particle times the charge of the gold divided by the radius or the minimum radius of the gold particle. Now, we want to look at the constants that were given to us in this problem. And what we have is that the alpha particle, which is the nucleus of a helium atom, is made up of 2 protons. So it's going to have a positive 2e charge. The gold has 79 protons, and it's going to have a charge of plus 79e. Now realize that E is going to be 1.6 times 10 to the minus 19th coulombs, because that's going to be the charge of an electron, right? So when we do the calculation, we need to incorporate that into there. And then the maximum kinetic energy of sending in the alpha particle is 1.33 times 10 to the minus 12th joules. So we're solving for R min. So our R min is equal to K, which is a proportionality constant, times the charge of the alpha particle, times the charge of the gold particle, all now divided by our kinetic max, or our maximum kinetic energy. Therefore, our R min is equal to K, which is 8.99 times 10 to the 9th Newton meter squared Coulomb squared times, now this becomes 2e. Now realize that when you do the calculation, you want to take 2 times 1.6 times 10 to the minus 19 coulombs. I'm not writing it out because I'm running out of space. Times now the charge of the gold, which is 79e. Once again, E is going to be 1.6 times 10 to the minus 19th. All right, now you want to divide this by our kinetic max, which is 1.33 times 10 to the minus 12th of a joule. So you're going to take our proportionality constant, which is what we saw when we talked about the electric force back at the beginning of the semester. That was the proportionality constant. We're going to take that times 2 times E, times 79 times E. Remember, E, you got to include that in the calculation. Divided by the kinetic max of the alpha particle. And what we end up getting for this is we get 2.7 times 10 to the minus 14th of a meter. So we're looking at something that's around the order. So you're looking at something that's around the order between a picometer and a femtometer. So really small unit, which is what you would suspect for the nucleus of an atom. It's something really small, very densely packed. But this experiment shows that there was going to be a nucleus, and from this calculation, we've now determined approximately the size of the nucleus of a gold atom. If you have any questions, please let me know.